Hello students, today we are going to discuss Euclid's division algorithm. Okay, now a farmer is thinking like this. All the grains are filled in two types of bags. They are of two different weights. One is 18 kg and the other is 84 kg. He told his servant, go to the shopkeeper and ask him to weigh the total weight of our grain bags. And the servant said yes. Okay, after returning from the shop, the servant said the shopkeeper told that the total weight of our grain bags is 632 kg. And the farmer said fine. Meanwhile, his daughter, she said, oh no, the total weight given by the shopkeeper is not correct. By listening this, the farmer was surprised. How does Siri know that the total weight told by the shopkeeper is wrong? Even if she doesn't know the number of bags of 18 kg and 84 kg which were sent. This is quite interesting. Now, let us try to understand how can we explain this. Before going to solve this problem, let us understand what is division lemma, which you already learnt. Suppose there are 7 marbles and we want to make it groups of 3 marbles each. How many groups can we make? And of course it is quite easy to understand that 2 groups can be made and 1 marble is left. The same thing we write it as 7 is equal to 3 into 2 plus 1. In this 7 is divided, 3 is divisor, 2 is quotient and 1 is the remainder, which is known as division lemma. Okay, if A and B are any two integers, of course B not equal to 0, then there exists two non-negative integers Q and R such that A is equal to BQ plus R, where 0 less than or equal to R less than B. This is known as Euclid's division lemma. Now we are going to make use of this division lemma for considering division algorithm. Division algorithm is a process, right? Now let us try to understand this. Here we are considering two numbers 8 and 12. So when we consider 12 and 8, out of those two the smaller one is 8 and the difference is 4. So next group is 8 and 4, and again out of 8 and 4 the smaller one is 4 and difference is 4. When the two numbers are equal, that will become the HCF. And in the process of ordinary division also already it is shown. And how do we write the steps? Let us see. 12 is equal to 8 into 1 plus 4, right? So if the remainder is 0, then 8 will become the HCF, but remainder is not 0. So we continue one more step of division algorithm. That is 8 is equal to 4 into 2 plus 0. Now 4 will become the HCF of 12 and 8. Of course we have to understand that 4 is HCF of not only 12 and 8, it is also HCF of 8 and 4. Now, so from this we can understand that if A is equal to BQ plus R, then if R is equal to 0, then B is the HCF of A and B. If R is not equal to 0, again we continue B is equal to some RQ1 plus R2. Now we can understand that the number which divides A and B also divides B and R. So we continue this process till the remainder is 0. This is what we have to understand. Now this algorithm process was given by the mathematician Euclid. That's why we call it Euclid's division algorithm. Now for this he considered two sticks of two different lengths, 50 and 35. Now in 50 units stick, if you cut 35 units, one stick can be cut and 15 units stick will be left over. Again with 15 units stick you have to make it into parts. The 35 unit stick you get two 15 unit sticks and one 5 unit stick is left. Now we are comparing 15 unit stick and 5 unit stick. How many times can we do this? 3 times. So 15 unit stick can be made into 3 5 unit sticks. So the same thing we write it like 50 is equal to 35 into 1 plus 15. Again 35 is equal to 15 into 2 plus 5. We can see 2 red colored sticks, 15 units length. And last one is 15 is equal to 5 into 3 plus 0. So 3 blue colored sticks, each of length 5 units. We continue this process till the remainder is 0. Of course, here we can observe that the remainder is 0. That's how we can say that 5 is the HCF of 50 and 35. What we have to understand here is 5 is HCF of not only 50 and 35, it is also for 35 and 15 and 15 and 5. Now, let us try to understand the same in one more way. For doing this, we are considering two measurements. Here I considered 57 and 36. With these dimensions, I draw a rectangle. Now, we have to make it into squares. Of course, 57 by 57 square is not possible here. So, the other possibility is 36 by 36 square. Just remove that 36 by 36 square. Then you are left with one rectangle of whose measurements are 36 by 21. Again, if we have to make a square, then it is 21 by 20. Then we are left with 21 by 15 rectangle. Again, from this we can cut one 15 by 15 rectangle. Then we are left with 15 by 6 rectangle. From 15 by 6 rectangle, you can make two squares of 6 units each. Then you are left with 6 by 3 rectangle. 6 by 3 rectangle means two squares, each of measurement 3 by 3. So from this we can understand that like 3 is the HCF. How do we write the steps? 57 is equal to 36 into 1 plus 21. Of course, here 21 is the remainder which is not 0. So what we are doing here is this 36 is taken like dividend and 21 is taken like the divisor, and again the process of division is continued. 36 is equal to 21 into 1 plus 15. Again, because the remainder is not 0, we continue with the process. 21 is the dividend and 15 will become the divisor. So 21 is equal to 15 into 1 plus 6. As we discussed earlier, we have to continue with this process till we get remainder 0. So 15 is dividend and 6 is divisor. 15 is equal to 6 into 2 plus 3. Again, 6 is equal to 3 into 2 plus 0. Means what does it mean? Here easily we can observe that 3 is the HCF. So 3 is the HCF of 57 and 36. Not only 57 and 36, it is also HCF of 36 and 21, 21 and 15, 15 and 6, and 6 and 3. For all these pairs, HCF is 3. This is what we have to understand. Now, means what does it mean? The measurements which we took are 57 and 36 and their HCF is 3. Means like if we have to make the squares which are to be arranged, like we can observe that only whole squares are to be used. Means 19 squares can be arranged along the length and 12 squares can be arranged along the breadth, and that's how we can get the rectangle, right? It is completely filled with squares. Now just I'm going to give you one small activity based on the same manner whatever we did earlier. So just I'm changing the dimensions. Draw a rectangle with measurements 28 and 44. Find the HCF of those two numbers by dividing the rectangle into squares, right? Now, one father is asking his son, how many tiles are needed for this hall? For that the son said, okay, if we know the dimensions of the hall, easily we can tell how many tiles are needed. Then his father said, okay, the length of the hall is 5.25 meters and width is 3.78 meter. So it is to be paved with square tiles of same size, and of course moreover only whole tiles are to be used. Then what is the maximum possible size of such a tile? The son was astonished what to do. Now how can we solve such a problem? Let us see. Actually 5.25 and 3.78 are in decimals. So to make them integers, first convert them into centimeter, then we get 525 and 378. So 525 is equal to 378 into 1 plus 147. So because the remainder is not 0, we continue with the process as we discussed earlier. So that's how we can see 378 is equal to 147 into 2 plus 84. Again, if we continue with the process, 147 is equal to 84 into 1 plus 63. And again 84 is equal to 63 into 1 plus 21. And finally, if you observe, 63 is equal to 21 into 3 plus 0. Now here in the last step you can observe the remainder is 0. Means what does it mean? 21 is the HCF of the numbers 525 and 378. Means we have to understand that only whole tiles are to be used. The largest possible side of such a square tile is 21 centimeter. Of course, the largest possible, why did we say? Because for 3, 7, 1 also it is possible. With only whole tiles the conditions will be satisfied. But out of all such possible values, the largest is 21 centimeter. Now I am going to show you one more interesting way for this. Take any a square rule paper, or even you can use a graph sheet. Whatever the two measurements that are given, in this particular example I took 8 and 4. Now by taking those two measurements as length and breadth, first draw a rectangle. Then after that what we have to do is draw the diagonal. So this diagonal line, if you observe, it passes through the corners of only few squares. How many such points are there? You count. You can see 1, 2, 3. There are 3 such points. So just simply add 1 to it. Just count the number of corners through which the diagonal is passing. In this particular example, it is passing through 3 corners. So for that you add 1. 3 plus 1 is 4. That's how we can say that HCF of 8 and 4 is 4. Right? That's how we can observe this. Now let us go back to the previous problem. Like at the beginning, one question is there, that is, actually the father was thinking, how does Siri know that the total weight told by the shopkeeper is wrong, even if she doesn't know the number of bags of 18 kg, 84 kg which were sent? Let us consider the 18 kg bags are say X and 84 kg bags are say Y. Then number of bags of 18 kg are X, so its total weight is 18X, and 84 kg bags total weight is 84Y. So the total weight must be 18X plus 84Y, which is equal to 632, which was given by the shopkeeper. Here the simple logic is left hand side 18 and 84, for which the HCF is 6. So whatever the 6 that is dividing left hand side, that also must divide right hand side. In this case, it is a quick observation that 6 is not a divisor of 632. That's why she could be able to say that the total weight given by the shopkeeper is wrong. Now, actually here, till now, using this algorithm, we learned how to determine HCF. Now, I'm going to give you something interesting. Can we find LCM using this method? You try to explore. Draw a rectangle with measurements 9 and 12. Using such rectangular tiles, try to form a square. How many such squares can be made? Will the side of the smallest such squares become LCM of those two numbers? You try to explore yourself. Okay, now whatever the Euclid's division algorithm we learnt, now I'm going to give you some problems on that. You try to solve. The first one is find the HCF of 52 and 117 using this Euclid's division algorithm. Second question is find the HCF of 341 and 661 using Euclid's division algorithm. And the third question is it possible to get HCF of two consecutive terms of the series 1, 1, 2, 3, 5, 8, 13, etc. other than 1? Okay, that's all for now. I am signing off. We will continue this with some other topic on some other day. Thank you.